Okay, so today we're going to simplify fractions. Like I said before, it's really connected to chapter 5. Just so you have to know how to factor in order to simplify fractions. But before we do that, let's remember some of the rules that we learned. Here's the first fact. What do you guys know about this? If I have A times B over C times D, is there a way to rewrite this in terms of product of two fractions? Yes, there is, right? Raise your hand if you remember. How do we do that? 1, 2, 3, 4, 5. Austin, what do I do? AB over C. That's what I have. AB over CD. So how do you separate this into multiplication product of? A over C times. Exactly. A over C times B over D, right? And if you wanted to, you could actually, because of commutative property of multiplication, you could write down A over D equals to B over C. Doesn't matter. But you get the idea, right? You can separate this. Now, here is, what about, question? Right. Go ahead. Well, what about this? Because a lot of people, when they see this, A plus B over C plus D, can I write this as A over C plus B over D? Is that okay? No, don't do that. That's really wrong, right? You can't, right? That's not correct at all, right? So please don't do. Could I write it this way though? A over C plus D over B over C plus D, where you have a common denominator of C plus D. Is that okay? Yeah, that's fine. But you can't separate it like this, can you? Like for example, I don't know. Maybe. So let me do this. Oops. This will be wrong. Like for example, if I have something like, I don't know, 3 plus 5 over 3 plus 7 or something. Does that equal to 5 over 7? Can I cancel out 3 over 3 like this and then 5 over 7 this way? Can I do that? No, of course not. It doesn't make any sense, right? Please don't do that, right? That's really wrong. Just because you have the same number on the numerator and denominator, like here, you can't cancel this out, can you? That's wrong. You see what I mean? Right? Okay, oh yeah, and then I should write this, I could write this as A over B times B over C, right? Using the commutative property of multiplication, right? It doesn't really matter. A over C times B over D, same as A over D times B over C. By the way, do I need to write restrictions? What's your restriction, by the way, for these? C can't be 0 or what? And or D can't be 0. So you need the restriction whenever you do these, right, guys? Because if C happens to be 0, the whole expression is undefined, right? If D happens to be 0, the whole expression is undefined. Question? Oh, this right here is because I could write this as A over B times D over C, right? Isn't this same as this? Using the commutative property of multiplication, and then you could write that, right? Right? C times D is same as D times C, right? Just commutative property of multiplication. So knowing this, let's do an example. Are we ready? Okay. And by the way, is it important to write down the restriction whenever we have variables in the denominator? Yes, okay? So you need to write down the restrictions, otherwise your answer is not complete, right? You will not get full credit if you do that. There you are. 2 over 4y. This is a very simple example. So how would you simplify this fraction? Anybody have an idea? Come on. How do you simplify this fraction, guys? This is Ryan? Divide top and bottom by 2. Yeah, I could show that work by just, well, we don't really, yeah, you could divide top and bottom by 2. If I was really being careful, I could have written this as, if I was using that rule that we had, whoops, I could have written down 2 over 4 times what? 1 over y. Could I have done it that way? Kind of, you know, going with that rule that we just learned. And 2 over 4 is, of course, half. So there you go. And do you see why I need this? Y can't be 0? Could I leave that out? No, then you will not get full credit, right? Because if you leave that out, you're saying this expression, 2 over 4y, is equal to 1 over 2y every time. The answer is that's not true every time. When the y happens to be 0, it will not equal to 1 over 2y, would it? It'll be undefined. You see what I mean? So if you don't put down the restriction, that means you're not telling us the correct answer. Does that make sense? It's not. You're only telling me one part of it, right? It's not always equal to 1 over 2y. There's one exception. When y is 0, it will not be. So you have to tell the readers that expression 2 over 4y will be 1 over 2y only if y doesn't equal to 0. Okay, let's look at example 2. By the way, any question? We good? Yes?
Wait.
Yeah.
Well, do we have to show like 2 over 4 times 1 over y?
No, yeah, for something simple, you could just divide top and bottom by 2. But it's good to kind of show work this way, because you don't make silly mistakes. You'll see in a minute that it's easy to kind of make silly mistakes on these. So there you go. 2t plus 6 over 5t plus 15. Very simple expression that's written as a fraction. So what should we do to simplify this? Is there a way to simplify it? Is this already simplified? I don't think so. I think there's a way to simplify this further. Okay. One person see it? 2, 3, 4, 5. Good. Sarah, what do you think? Oh, you sure? Okay. Lucia, what do you think? Oh, so what do you want me to write? Tell me what to write.
2t over 5t plus 15 plus 6 over 5.
Oh. You read my mind. Like this, right? And then cancel out the t's like this? Remember, that's what I told you can't do. You could only do this if this is multiplication. If it's addition, remember I told you can't do it this way. If it was a plus b over...
2t over 5t plus 15.
Plus what?
Plus 6 over 5t.
Oh, you want me to separate it? Okay, you want me to separate it with 2t over 5t plus 15 plus 6 over 5t plus 15. Oh, you could do that. It's just, it doesn't help you too much to simplify, does it? Oh, I thought you said this. Okay, so you know this is wrong, right? You can't do it this way. Okay, see? Like I even gave you example, right? 3 over 5, 3 plus 5 over 3 plus 7, they're not equal to, it doesn't equal to 5 over 7. Okay, so we just went over, okay, oh, but yeah, if you do it the other way, it doesn't really help you too much. Kaylee, you have an idea? What should I do?
Yeah, okay, so
Hold on, question?
honestly, both of them.
Oh. So, yeah?
Okay, so the numerator would be 2 times t plus 3, and the denominator would be 5 times t plus 8.
What's Kaylin doing? What is that called? We are factoring out your GCF. Does that sound familiar? How many times have we done that? Many times, right? Now, when you do that, nice thing happens. Now, you could use the fact that I showed you before. Right? If it's a times b over c times d, you could separate this into two fractions. And what happens? Same thing over same thing is? What's same number over same number? Cancels out and it's 1. You're dividing top and bottom by t plus 3, aren't you? Okay. So the answer is 2 over 5. That's how you get it wrong if you write it that way. Okay. If you write 2 over 5, you will not get full credit. Maybe I'll get you half or something. But why not? Isn't that the answer? That's what we get, right? T plus 3. You divide top and bottom by t plus 3 over t plus 3. Doesn't that become 1? So you get 2/5. Stefan, why not? Why isn't this my answer?
Because you have to take the restriction.
Oh, gotta write the restriction. Sarah, do you see my restriction? What's my restriction for this? When will this not be equal to 2/5?
T plus 3.
Yeah, we have to make sure when the t plus 3 can't be 0. And we don't normally write t plus 3 can't be 0. We just simplify it a little bit. When will t plus 3 be 0? The one on the denominator, right? When would that be 0? When t is equal to -3. So that's what we write down. Any question? You get it or no? Does that make sense? Right? We're looking at this denominator t. See, I even highlighted for us, right? We want to make sure we were thinking in our head. I think I wrote this down. So here, see right here. We're thinking in our head, when will t plus 3 be 0? Does this sound familiar? Haven't we done this before when we're solving? Right. And we actually did this when we're doing restrictions, right? First, and then. So we're thinking in our head, when will t plus 3 be 0? Well, you add negative 3 to both sides. When t is equal to negative 3, wouldn't that be 0? So we have to make sure to write that in there, because that expression, 2t plus 6 over 5t plus 15, will not always be 2/5, would it? It will be always 2/5 every time, except when t is equal to? When t is equal to? When will that expression not be 2 over 5? When t is equal to? Hello? Yes? Negative 3. When t is negative 3, right, your denominator turns to be 0. Actually, it turns out this time the numerator turns to be 0 too, but does it matter? Do we care about when the numerator goes to 0? Not really. When we're simplifying expressions, we don't mind numerator being 0, because 0 over some number is 0. That's fine. But what happens when denominator is 0? Then the whole expression becomes undefined. Does that make sense? So that's why I highlighted the t plus 3 on the denominator, right? That's what we're looking for. We don't mind the numerator becoming 0 for these expressions. That's fine. It's just that when denominator goes to 0, that's undefined. Any question? Does that make sense, guys? So no one will write down 2/5, right? That's the answer. You will give me the restriction. Does that make sense? Even though the t's cancel out, right? Before you cancel out, you have to look at the restriction. Does that make sense? The t plus 3 over t plus 3, they cancel out, yes. You don't see it anymore, but it was there originally, okay? So you can't forget about, just because you cancel things out like this, you can't forget about what makes the denominator of the original expression go to 0. So take a look at example 3. Why don't you try this on your own? So I'll give you some time. It looks a little bit different than the other one, but not that much different. So everybody go ahead and try on your own. Give you some time, okay? So what should we do here first? Anybody see what to do first? 2 people. William.
Factor out the GCF in the numerator.
Factor out the GCF on the numerator. What is your GCF for the numerator? William? 2. That's correct. So tell me what to write when I do this. Eddie?
Get 2 times t plus 1
Over? Okay, well, yeah, you're right. Okay, so we get this on the numerator. Austin, what can I do with the denominator? T squared minus 1. Could I factor that at all? Yeah, how? If I do t times t minus 1, I don't get t squared minus 1, do I? Because if you were to distribute the t, you don't have t here, do you? So how do I factor the denominator? Isn't that something squared minus something squared? Isn't 1 really 1 squared? Right, Austin? Yeah, it's difference of square, isn't that right? Did you guys see that? Okay, now I could actually rewrite this way. Isn't it really the same as t over t minus 1 times t plus 1 over t plus 1? What's t plus 1 over... No? Okay. Ali, so what's t plus 1 over t plus 1? Yeah, what's my answer, Ali? You mean t minus 1, not 2. Yeah, how many restrictions, guys, would you get? Raise your hand. How many restrictions do you think we're going to get here? Raise your hand. Show me with your fingers. How many? 2 is correct. Why 1? It will not be 1 because, look, you have 2 factors that makes the denominator go to 0. Right? Viviana, do you know one of them? When will... Okay, so we know that the answer is going to be 2 over t minus 1, right? Now, what's one of the restrictions? T can't be 1. Or, what's the other restriction? Yeah, right now, if t... Look at what I have right now. If t happens to be 1, right? Doesn't that make the simplified fraction to be 0? I mean, denominator go to 0, so it's undefined. What's the another restriction? We cannot forget about the... Yes. -1. Why, Kayleen? Yeah, there's a t plus... Even though we cancel these out, you can't forget about those because it belonged to our original expressions, right? Does that make sense? So we're really simplifying this original expression, and whatever that makes original expressions denominator go to 0, we have to write them all out, right? Just because you cancel them out, right? You could forget about it. Just like, you know, isn't that what we did for example 2 and 1? Right? Look, even though they all canceled out, didn't we say, like here, t can't be negative 3, right? Even though it cancelled out, right?